Okay, so right now, across the corporate world, companies are throwing, just staggering amounts of money at AI.
It's really something.
Yeah, we're talking massive, rapid investment into the current generation of AI chips. Just to give you an idea of the scale, one major supplier estimated to have sold 500,000 of these chips in just 1 quarter.
500,000. That's an enormous amount of compute power hitting data centers basically right now.
Exactly. But that creates this, almost immediate economic problem, doesn't it?
It does. Our sources are really digging into this crucial question that's, just a few months down the road. What happens when the next generation arrives? Chips that are even more powerful, maybe more energy efficient.
Right. So if these big companies have to swap out those hundreds of thousands of chips to stay competitive, what happens to the old ones? They're still powerful, but suddenly they're being deinstalled.
That's the core of it. A massive pile of powerful, but maybe commercially less desirable AI hardware.
Seems incredibly wasteful and really expensive. Why would they swap immediately instead of, optimizing what they just bought?
That's exactly what we're unpacking today. We're looking past just the speed boost of the new silicon.
Okay.
We're diving into the vibrant resale ecosystem, as our sources put it, that this turnover is bound to create, and how that could actually make AI much more accessible for, everyone else.
Okay, so let's set the scene. Right now, these current AI chips, they're the standard hardware, right? The workhorses for things like complex chatbots, the big language models, image generators.
Pretty much the foundation. Most companies have built their whole AI infrastructure around this specific generation of silicon.
So why the rush to upgrade? What's the financial driver you mentioned?
What's fascinating here is that these new chipsets, they aren't just like incrementally faster. It sounds like they're designed for a really significant leap in efficiency.
More efficient.
More compute power? Sure, that's expected. But the real game changer seems to be much lower energy use per calculation. And critically, much tighter integration with the software.
Tighter integration, what does that actually mean for, say, an IT manager looking at their budget?
It means the chips themselves have specialized features built right into the hardware. Things optimized specifically for the kind of math AI models rely on.
Okay.
Often moving from, standard energy-hungry math like FP32, floating point, to more specialized low-precision formats, maybe like FP8. And when the software, which often comes via new SDKs, software development kits, is written to actually use these new instructions, the performance gain per watt can be huge, massive.
Okay, so it's like the classic next-gen smartphone effect, but for AI data centers dialed way up.
Exactly. Your old chip still works. It's not broken.
Right.
But the new one is so much more efficient that running the old one starts looking like a bad financial decision almost immediately.
An economic penalty, yeah.
Precisely. If a new chip does the same work using, say, 3 to 5 times less electricity, for huge data centers spending billions on power and cooling, they almost can't afford not to upgrade.
So these next-gen chips, they speed up AI, drastically cut running costs.
And open up completely new use cases, things that were just too expensive or too slow to really deploy widely before.
And because they're so much cheaper to run, you said they push AI out of just the big data centers.
Absolutely. Our sources are definitely pointing to this shift towards decentralized computation. These new chips make it possible to run sophisticated AI on what we call edge devices.
Your phone, cameras.
Their phone, cameras, sensors in a factory, maybe even traffic lights in a smart city.
Wow.
This allows for real-time analysis right where the data is generated without constantly sending massive amounts of data back and forth to some remote power-hungry cloud server. That's a really big change in how you design the infrastructure.
Okay, let's bring this down to earth.
Yeah.
What are the direct effects that you, the listener, the user, will actually notice in everyday services?
Well, the first thing is probably speed and quality. You can expect faster, smarter services. Think instant responses from chatbots or virtual assistants. Less of that lag we sometimes get now.
Yeah, that delay can be frustrating.
Exactly. And it's not just speed. The quality of the output should improve dramatically too.
How so?
Because that energy efficiency means you can run bigger, more complex AI models more often, more affordably. So you're looking at sharper, more accurate images from generation tools.
Okay.
Translation services that actually grasp context much better. Recommendation engines that feel, genuinely insightful, not just repetitive.
And you mentioned cost savings earlier. Those sound potentially huge.
They really could be. From an economic angle, if the new chips use live electricity for each task, cloud providers can eventually pass those savings along.
So maybe lower subscription fees for AI apps?
Potentially, yeah. If you use a lot of AI-powered services, maybe advanced writing assistants or photo editing tools, you might see those costs come down over time. It depends on the provider, of course, but the potential is there.
And what about devices becoming more affordable? You touched on that.
Yes, that's more of a long-run effect. When things like phones and home assistants have powerful, efficient AI processors on the device itself.
Right, the edge AI thing.
Exactly. They save money on data costs because they don't need to constantly call back to the cloud for every little task. The processing happens right there, locally, almost instantly.
Which saves me money on my data plan.
And it also cuts down on that latency, that delay, that makes some current home assistants feel a bit slow or clunky sometimes.
Okay, this is where it gets really interesting for innovation, for businesses maybe outside the usual tech giants.
This efficiency wave, it really unlocks completely new business opportunities.
Yeah.
Think about smaller AI startups.
Yeah.
Maybe they were previously priced out because training and running the big models was just too expensive. Now they might be able to enter the market. They don't necessarily need those massive data center budgets right away, especially if they focus on specific niche applications.
Can you give us an example or two? What kind of industry-specific tools suddenly become practical?
Sure. Think about, say, agriculture. Farmers needing real-time crop monitoring. Before, you might have had to send huge batches of images from a drone back to a cloud server for analysis.
Right, slow and data heavy.
Yeah. With efficient edge AI, the drone itself, or a sensor in the field, could potentially do object detection, check plant health, and help make immediate decisions right there.
Wow, okay.
Or think about healthcare. Doctors getting rapid diagnostic support from models running on local machines within the hospital.
Which keeps patient data secure.
Exactly. Keeps sensitive data on site and provides instant feedback where, a delay could be really critical.
So this isn't just about hardware, it's a major workforce shift too, isn't it?
Absolutely. You'll see increased demand for new skills, people focused on integrating AI into everyday products, deploying these models effectively at the edge. But there's also a critical need for companies to invest in reskilling their existing IT teams. They need to handle adopting this complex new hardware, sure, but also manage and maintain the previous generation of silicon that's still running important tasks. It's a dual challenge.
Okay, so we've established new chips mean massive efficiency gains. Big companies, the hyperscalers, they pretty much have to upgrade fast to save money.
The economics almost force their hand.
But that leaves this huge, expensive pile of perfectly good, powerful hardware getting pulled out of servers. Which brings us, I think, to the core insight here. This creates a massive secondary market.
That's right.
And to explain this, you mentioned the used-Xeon market analogy.
Yeah, it's a really good parallel. Intel Xeon chips, they've been the workhorse processors for enterprise servers and workstations for, decades now.
Yeah.
Kind of the backbone of traditional corporate IT.
Right. So what happens when newer, faster Xeons come out? Those old ones don't just disappear, do they?
Not at all.
Yeah.
There's a really vibrant, essential secondhand market for Xeons. When a big bank or a massive cloud provider upgrades its servers, they don't just trash the old ones.
They sell them on?
They sell them. And these used chips, now available at a steep discount, get snapped up and repurposed.
For what kind of tasks?
Typically lighter stuff, maybe small business accounting servers, specialized development labs where you need decent compute, but not cutting-edge speed. Educational institutions are big buyers.
Okay.
Or even niche regional cloud providers who maybe can't afford the absolute latest and greatest, but still need reliable compute.
So the older hardware kind of cascades down the computational food chain.
Exactly. It's often called the cascade effect in hardware life cycles. And we can directly apply that pattern to these AI chips.
Okay, how?
When the newer super efficient AI chipsets really hit the market and the big players start deinstalling the current generation in large numbers, those current chips are going to see an immediate, probably dramatic price drop.
Like a price shock.
Yeah, and they'll find new homes pretty quickly.
But the really crucial distinction here, isn't it, is that these older AI chips are still incredibly powerful. They were running state-of-the-art AI just weeks before being pulled.
That is the absolute key point. They're still powerful enough for a huge range of organizations that need AI compute, just maybe not the absolute bleeding edge speed or that hyper efficiency demanded by the world's biggest data centers.
And that huge price difference, that's the democratization moment you mentioned.
That's it. Suddenly, serious AI compute becomes accessible.
So who's buying these refurbished AI chips then? Who benefits most?
You're probably looking at three main groups initially. First, startups, especially AI startups.
Right.
They could potentially buy, say, 3 to 5 times the compute power on the secondary market for what one new chip might cost. Maybe they use it for local inferencing, running trained models on customer data where constant retraining isn't the main bottleneck.
Okay, who else?
Second group, research labs. Think universities, specialized medical research facilities. They can acquire immense processing power for things like long-running simulations or data analysis, where having the absolute latest gen isn't the top priority, but having lots of compute is.
And the third?
Regional data centers or smaller cloud providers. They can suddenly start offering competitive AI services to local businesses without needing that massive upfront capital expenditure for only the newest hardware.
So this whole process creates a much longer life cycle for the hardware. The older chips keep delivering real value for years.
Just like used-Xeons have done for IT departments everywhere for ages.
Yeah.
It creates this really crucial sort of safety valve for innovation, keeping hardware productive. The big takeaway really is that this vibrant resale ecosystem makes powerful AI capabilities genuinely accessible to smaller players, innovators who were previously kind of locked out by the sheer cost of entry. It could dramatically accelerate AI adoption globally.
Okay, so this hardware wave, it sounds like it's cresting right now, or very soon. Let's pivot to actionable steps. If you're listening to this and thinking, okay, I need to stay ahead of this, what should you be doing? Maybe a quick checklist, depending on your role?
Yeah, the preparation definitely looks different depending on where you sit. If you're a large enterprise, one of the big players, you need to be aggressive. Start pilot projects on the new chips immediately. You need to understand those energy savings firsthand.
But don't just throw out the old ones.
Absolutely not. You also need to keep a really meticulous inventory of your older chips. Why? Because they can be strategically repurposed internally, maybe for legacy workloads that aren't performance critical or for internal R&D projects. Extend their value within your walls before just discarding them.
Okay. And what about the smaller players, the SMBs, the startups who are eyeing those potential cost savings?
For them, the advice is watch the resale platforms and the hardware refurbishment specialists very closely, starting now.
Be ready for that price drop.
Exactly. That price shock is coming. And you need to actually budget specifically for potentially buying refurbished hardware.
Yeah.
It's a strategy to really stretch your funding rather than relying only on, say, expensive low-latency cloud compute. You're trading that peak efficiency for a massive cost advantage.
Right. Now, what about the people building the software? The developers, the engineers, what should they focus on learning?
For them, it's about education and cross-compatibility. Yes, absolutely. Keep learning the latest SDKs, the software development kits for the newest hardware. You need those skills.
That's bad.
But crucially, think about ensuring your AI models can maintain compatibility where possible with the older used chips too. Because that resale market, that's where a lot of your future clients, innovative partners, and maybe even employers will be operating. Don't ignore that segment.
Makes sense. What about just the average consumer? Is there anything we should look for when we're buying new tech?
As a consumer, yeah, I think you should start looking specifically for devices that really tout robust on-device AI as a key selling point.
Because that signals the new efficient chips.
That's likely a sign they're leveraging this newer, highly efficient silicon. And that usually translates to better privacy, since less data leaves your device, better overall performance, and less reliance on a constant internet connection for smart features.
Okay, so let me try and quickly recap those key preparation areas. We've got review your budget, potentially for refurbished gear. Assess your talent. Do you have people who can integrate these new processors? Make sure your software models are flexible. Have a resale strategy in mind, whether buying or eventually selling. And keep an eye on sustainability. Track the energy impact of whatever compute path you choose.
That covers the main areas, yeah.
Yeah.
It's about being prepared across the board.
So the bottom line seems pretty clear, as we've discussed. This rollout of new AI chipsets, it's poised to make AI faster, cheaper, and honestly just vastly more available everywhere. For the really big players, it's about pushing performance boundaries and grabbing those significant cost savings through better efficiency. But for the rest of the world, smaller companies, innovators, researchers, that secondary market for used but still powerful hardware, that unlocks capabilities that were maybe completely out of reach before.
And that democratization, it's potentially transformative. However, it does raise a really important question, one the sources definitely highlight.
Which is?
Well, The industry clearly needs to adopt these new energy-efficient chips that's good for costs and the environment, and they also need to recycle the older hardware responsibly. We know the secondary market will boom, keeping chips useful for longer, which is also good. But the question for you, the listener, to really think about is this. As every major company puts this massive focus, this huge financial priority on getting and deploying the latest shiny new chips, how does that intense focus potentially affect the investment, the attention, the infrastructure needed for the sustainable, responsible recycling and integration of the powerful but ultimately discarded older hardware down the line? Are we solving one problem while potentially neglecting another?
That's a really critical thought. Managing the e-waste and the full life cycle created by this incredibly rapid technological churn, definitely something to watch. So make sure you track both the performance claims of the next-gen chips and the price dynamics hitting that secondary market. It'll help you make smarter, more economical, and hopefully more sustainable decisions in this AI age. Until next time, keep exploring, keep questioning, and keep diving deep. Thank you for listening to today's podcast. Please feel free to click on the link in the description below to discover more podcasts.